Hello class, today what we're going to talk about is transformation of polynomial graphs. Okay, so we're looking how can we take the graph and move it to the left, to the right, up, down, stretch, shrink, flip it over, spin it around, all that good fun. And if you'll notice, we start off, we have the same a, b, h, and k that we've had on every function we've ever talked about. It didn't matter if it was linear or quadratic or cubic, whatever, it doesn't matter. We have the same transformations. Same a, b, h, and k. And you'll notice they do the exact same things in polynomial functions that they did in quadratic functions or in linear functions or in absolute value functions. All right? And so a horizontal translation, that's the h. All right? And remember that it's x minus h, so it's going to look backwards. All right? So here you have x minus 5, and so that's going to move it positive direction because h is actually a positive 5. And here we have x plus 2. H is actually a negative 2, so it moves it to the left, even though it looks like it's going to go to the positive. Remember, everything in the parentheses looks backwards. Okay. Vertical translation, that's your k again, same as usual. Plus moves up, negative moves it down. Reflections. Remember, if you've got a negative inside the parentheses, so just to the x, we've got a negative b, that's a flip over the y-axis. That's a horizontal movement, so it's inside the parentheses. Negative f of x, that is a flip over the x-axis. That is a vertical movement, so it's on the outside of the parentheses. It's to the entire function. Horizontal, just to the x, vertical, to the whole thing. Stretch or shrink, horizontal, that's your b. So you're multiplying just times the x. It's a horizontal move, so again, this is inside the parentheses. Also, since it's horizontal, since it's inside the parentheses, it's going to look backwards. It's going to look all messed up. So if I want to shrink it, I'm going to use something larger than 1. So here I have a b value of 2, which means I have a shrink by a factor of 1/2. Here I have a b is 1/2, which means we have a stretch by a factor of 2. It's reciprocal because we're multiplying. Well, but in effect, we're actually doing is dividing, so it flips it over. All right, last one we have is vertical stretch or shrink. This is a, and this is multiplied by the whole thing, and a does what it says it should do. Multiply by a big number, it gets bigger. Multiply by a small number, it gets smaller. All right. Okay, so let's take a look at this, see how this works. So we need to describe the transformation of the function and then graph it. Notice it wants us to describe the function, what's happening first, and then graph it. So here's our parent function. All right, f of x equals x cubed, that is the parent function. And what we want is x cubed minus 9. All right, well, that minus 9, that's in the k position, so that moves it down 9 units. So it's a slide down 9 units, and then we graph it. So first we graph our original. There's the original. Yours will probably look a little steeper than mine. Notice my scale, I'm going up by 2s here. And then we graph the new one. We move down 9 units. So everything just comes, it slides down 9 units. That's all it is. So I'd like you to pause the video and try number 2. Alright, so you're back. Let's see how you did. Here's our original function, our f of x, which is x to the 5th. And what we want, we have x plus 1 to the 5th plus 2. This is inside the parentheses, so this is an h. And so it's also backwards. So h is negative 1, which means we're actually moving to the left 1. This is a k, it's on the outside, addition, and so that's going to move it up 2. So shift up 2 units, shift left 1. Here's the original. And our new one should be right there. Moved over 1 and up 2, which doesn't look like it moved that much because my scale is going up by 5s on this one. So yours probably looks a bit steeper. Okay, let's try a couple more of these. I've actually got the originals already drawn on there. I want you to pause the video and take a look at this, see if you can figure out what the new functions are going to look like. Try to come up with the description of the transformations before you graph the functions, just by looking at the equations, okay? Okay, so hopefully you did that. Let's see how you did. On number 3, we have a reflection over the x-axis. That's this negative right here. Vertical stretch by a factor of 5, and then it was shifted 2 units to the left. So our new function is right there. Again, my vertical scale is going up by 5s. My horizontal scale is going up by 1s. So yours probably looks a bit steeper than mine does. Okay, on number 4, see what you did there. Here we have a horizontal stretch by 2. Remember, it's in the parentheses, so it's horizontal and it's backwards. All right? So it looks like you're getting smaller, you're actually going to be getting larger. So this is a horizontal stretch, so remember this time it's going to get wider. Over here on number 3, this was a vertical stretch, so it got taller, it got steeper. All right? See how this is a lot steeper than that one is? This one is going to be getting wider, it's going to be twice as wide. And then we slide it down 4 units. So this is going to look like that right there. Slid down 4 units, and it is a lot wider, you see. Okay, what do we got here? Alright, 2 more. Let's try these. These are a little bit more complicated, but not much. Everything looks exactly the same. So pause the video, see how it goes, and then come back. Alright. So what do we got here? We have a negative x, so that's in the B position. It's negative, so it's a flip. It's in the B, so it's horizontal, so it's going to be flipping this way over the y-axis. And we've got that negative 9 there, that's in the K position. So we have a flip over the y-axis and slid down 9 units. And so this is going to be right, there it is. So from 8 down to negative 1. My graph is a little bit high, but it's going to be right there. Okay. Now, so here, again, it's starting off in a different place. It's not starting at the parent function, but that's okay. It's still going to be just a move from wherever it was to begin with. So here we have the 5. It's on the outside, so that's in the A position. So it is a vertical stretch by a factor of 5. So it's going to start right where it was, and everything's going to get 5 times taller. Alright, so that puts it right there. Now notice this looks like it was a slide, but it's not. It's just that it started at 1, and that 1 also got 5 times taller as well. Okay, so this is not a slide here. This is just a stretch from where it was to begin with. Okay, now let's do something a bit more complicated. Here they want us to write the function of the transformed graph. All right. So we start with f of x. We're going to translate it 1 unit left, followed by a reflection in the x-axis and a vertical stretch by factor of 2. Now, here's the thing. Since it has some transformation happening, followed by some other transformations, we're going to do this in 2 steps. So instead of going straight from f to g, we're going to have function for h as well. That's just going to do this first part. Okay. So 1 unit left, that's the horizontal move, so that's your h position. It's left, so we're going to have x plus 1. Right, so h of x is going to be f of x plus 1. So we need to add 1 to all of our x's, which isn't too bad, except we have x in 2 places, and so we have to do this x plus 1 in both of those places where we have the x. And now we have to simplify this, which means we're going to need to expand this out. We have x plus 1 cubed and x plus 1 squared. Those have to be expanded. You can either go and FOIL it all out, or you can use Pascal's triangle, which is much, much faster if you can remember the patterns. All right. Well worth it to go back and remember how to use Pascal's triangle for this. So we expand these both out, and this one becomes x cubed plus 3x squared plus 3x plus 1. And our next set here becomes x squared plus 2x plus 1. All right, now we need to distribute that negative 6 in. Nothing to distribute there. And so the negative 6 gets distributed in, combine like terms. There's h of x. So that takes care of it all, just this one transformation. Now we're going to do this other 2 transformations. So we have this followed by that. So we can do all of this together because it's all happening at once. So a reflection in the x-axis, well, it's a reflection, so it's negative. It's in the x-axis, so that means it's going this way. That's vertical, so it's going to be on the outside. So that's in front of the whole thing. And then we want a vertical stretch by a factor of 2. Again, vertical, so it goes to the whole thing, so that's out in the front. So that means our g of x is going to look like this. -2 times whatever h of x is. Now notice there's nothing here happening inside the x, so that means all of this is just going to be replacing like this. So it's just -2 times everything that was h of x. So -2 times h of x. So just took h of x, plugged in there. And we distribute that in, and we end up with our g of x. And so this is our answer. Okay? So yeah, that one takes a little bit more work. Okay? Take it step by step by step. Okay, don't try to do it all at once or stuff will get mixed up in the middle. So first do whatever is listed first, and then when it says followed, do that as a separate transformation, a separate set of transformations. Okay. Now the tricky part on this, the part that people forget, is after they plug into the x here, you've got to expand these exponents. Okay. These binomials have to be expanded, and then you can combine like terms. All right, so here we go. I want you all to try this one on your own. Pause the video, work it out, then come back and see how you did. All right? Okay, so let's see how we did. Here's our f of x. We need a horizontal shrink by a factor of 1/3 and a translation 8 units down, followed by a reflection on the y-axis. So this stuff is going to happen second. This stuff happens first. We're going to do this in 2 steps. We're going to make an h of x and then a g of x. So h of x, horizontal shrink by a factor of 1/3. It's horizontal, so it's inside the parentheses, and it flips it over. Okay. Remember, everything horizontal looks backwards. So it looks like multiplying, but we're actually going to be dividing by 1/3, so it comes with that. 8 units down, that's k, so it's on the outside. It does exactly what it looks like. So take the 3x, plug it in for all of the x's. We take the -8 and we stick it on the end because it's outside the parentheses, so it just gets tacked on to the whole thing. Next, we need to expand all of these. So again, much easier if you remember your Pascal's triangle. Well, actually, these don't have to be expanded because it's not pluses. So this one's actually a little bit easier. So now we take these, we multiply these together, and we get this. Find my terms, multiply all that. Now we're going to do that followed by the reflection in the y-axis. So that's just a reflection. It's a negative. It's in the y-axis, so that's a horizontal move. So it's just to the x. All right? So we're just going to take all these x's, and we're going to make them -x. All right? So that's easy enough. There it is. Now remember, this does not just change all of your signs, because if you have -x to the 4th, that's still positive. All right? -x to the cubed, though, that is negative. And if you remember this from Descartes' rule of signs when we did this, the only signs that are going to get changed are the ones that have odd exponents. So this is the only one that actually changes from our h of x we had right there. All right. And so there it is. All right. Again, that just makes this one negative, but the rest stay the same. Okay. And that is transformations of polynomial functions. Little bit tricky. The only part that's really tricky to this is you got to plug it into every single one of the x's. That's it. Plug it into all of those x's and then expand these binomials like we did on number 10 here. Other than that, it works exactly like transforming linear or absolute value or quadratic. It doesn't matter. They all work the same way. Okay. That's it. I hope it helps, and I will see you all next time.